primary protocol on layer 3 is called IPsec, which stands for IP security. IPsec is a collection of technologies to aid in guaranteeing these four main goals. Data confidentiality, which is achieved by encrypting data before transmission. Data integrity, where peers can determine whether a received packet was changed during transit. Data origin authentication, where a receiver can validate the identity of the packet sender. And anti-replay, where a receiver can detect and reject spoofed packets, protecting it from spoofing attacks. There are two core network protocols involved: ESP, which stands for Encapsulating Security Payload, and AH, Authentication Header. These are used by IPsec to achieve its goals. AH can provide for the last three goals, however provides no confidentiality because no encryption is used. It aids in IPsec's goals as follows. Data integrity is accomplished via hash calculation of the entire packet. Origin authentication, since the source IP is included in the hash data. Replay protection because of IPsec sequence numbers on the packets. The problem, though, is that AH is broken when passed through an NAT. When an authenticated packet goes through an NAT, the IP address in the header changes and the hash calculated by the receiver is incorrect, thus rejecting the packet. There is no way around this. The fix, then, is to use ESP or no NAT. ESP provides for data confidentiality as well as everything AH provides. It does this by not including header information in the authenticated data, allowing the packet to pass through NAT devices. Encryption is done after authentication, so a receiving packet can verify authenticity before decryption is expensive. AH and ESP can operate in two modes: tunnel and transport. Tunnel mode is used when an already established channel exists between site-to-site VPNs. Tunneling involves encapsulating the entire original packet and creating a new IP header. Transport mode only affects the data portion of an IP packet and leaves the IP header intact. Transport mode is used when the receiver and sender are the endpoints. For example, two hosts talking directly to one another. Internet key exchange is a large topic in itself, so I'm not going to spend any time on it. Essentially, it's a group of technologies like cryptographic algorithms used to authenticate, encrypt, and decrypt packets. IKE is used by both ESP and AH for various tasks. Some of the pros of IPsec. It uses network layer for its implementation, which means it's application independent. Users don't have to configure applications to adhere to IPsec standards. IPsec can be used to secure any protocol that makes use of IP and can also take advantage of any medium carrying IP packets. It's also a useful security measure against high-level protocol attacks like a man-in-the-middle attack. Some downsides of IPsec. First, it's an open protocol, which means vendors can have different implementations, which results in device conflicts. It's tightly coupled with the operating system, so there's longer packet processing time. There's no user control or user ID. Instead, some other access control needs to be implemented. It requires IKE, which creates additional overhead. And it's not backwards compatible with either ATM or frame relay networks.